Which alkyl halide from the following pairs would you expect to react more rapidly by an SN2 mechanism? Explain your answer. So they are given three pairs of compounds. So what is the question here? It is about the SN2 mechanism. So first of all, uh, you should know the difference between SN2 and SN1. SN2 is a nucleophilic substitution second order reaction. Nucleophilic substitution second order. And here nucleophilic substitution first order. If it is a SN2 mechanism, it is a single step process, whereas this is a two-step process. So first of all, you should know about the nucleophile. Nucleophile means it goes in search of carbocation, carbonium ion or carbocation. So in that case, it should be electron rich. Is it not? For example, it can be OH minus. Okay. So this nucleophile should be electron rich or negative so that it approaches the positive cation, and that is why we call it nucleophilic substitution reaction. For example, let us consider the hydrolysis of methyl bromide. So here, let me say CH3Br. Now the attacking species is OH minus, that is the nucleophile. So this is the attacking species, this is the nucleophile, and this is called the leaving group, right? So in the case of nucleophilic substitution second order reaction, it depends on order means that the speed of the reaction depends on the concentration of the reactant. So here the speed of the reaction depends on the concentration of this Rx. The speed of the reaction depends on the concentration of the substrate. What is the substrate here? Which is nothing but the Rx. Is it not? And this is the substrate where the nucleophile is going to attack. This is the attacking species nucleophile concentration. So the speed depends on the concentration of both, and that is why it's called the order is 2. But it takes place in a single step. How it takes place in a single step? That is attacking and releasing. They take place simultaneously. And it forms a transition state. So I'll explain in the next page. So here, let me take the substrate. That is CH3Br. The attacking species is OH minus. This attacks, and this is relieved. This is a leaving group. This is the attacking nucleophile. So that forms a transition state. So this becomes in a single plane like this. You can have a triangular plane like this. All these three will be in a single plane. On one side, the relieving group is going like this. So this is the leaving group Br as delta minus. And this is the attacking species. It is going to attach OH. So it's having, so this is plus. Okay. And this forms a transition complex, intermediate. And immediately after the release of this one, now it forms H, 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 and this side OH. You can find the change of geometry here. For example, the leaving group Br is on the right side. Here, OH is on the left side. So that is why it's called backside attack. Backside attack of nucleophile. And there is a change of geometry also. So these things should be noted down. Geometry. Okay. Change of geometry. Right. So when there is a change of geometry, that is because of what SN2 mechanism. So SN2 is favored by primary, then secondary, then tertiary. It means primary is given much important. Okay. So whether the reaction, so whether such, I mean, in such cases, it is asked as SN2, which is favored. So in this case, what you're supposed to do, you look for primary. If primary is there, that is supported. If secondary and primary is there, primary is supported. If tertiary, secondary and tertiary is there, secondary is shown. Okay, so this is the grade, and that is the priority. And in the case of SN1, this is a two-step process. So first here, formation of nucleophile. So here what happens? This is in the case of tertiary. So let us have CH3, 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 and Br. In this case, because of the bulkiness of the alkyl group, so it becomes C, CH3, CH3, CH3 plus Br minus. So first ionization takes place. You know very well for ionization which solvent is increasing? Polar solvent influences. So polar solvent like water encourages the ionization, and that too with the tertiary because it's already bulky, so they have the tendency to remove the Br. Okay, so this is the stage one, first step. Second step is attack of nucleophile. So here you have got already CH3, CH3, CH3 plus here this Br can attack from both sides. That's why it is called both side attack. Okay, it is called both side attack, right? Okay, and that results what there is no change of geometry here. Therefore, CH3 thrice C and then OH. You are able to get the tertiary alcohol. Okay, and the leaving group has already left in the first step itself. Got this point? So that is why we consider this as the line gun. Is it clear now? Okay, so SN2 versus SN1. And the SN1 is much encouraged by polar solvents. Here, non-polar solvent. SN2 is non-polar solvent influences, whereas here, polar solvent influences. And not only that, the priority is tertiary first, followed by secondary, followed by primary. Okay. So once you are thorough with the concept, then only you will be able to solve this problem. For example, now you can go through that. Which alkyl halide from the following pairs would you expect to react more by SN2, more rapidly by SN2? So immediately you have to note down this is SN2, question number 6.7, point number 1. So SN2 priority is there. So for which, what is the thing? First you have to note down polar, non-polar solvent. but there is no discussion about the solvent here. You can ignore it. So non-polar solvent. Second is primary, followed by secondary, followed by tertiary. So, but primary is given. So, for instance, CH3, CH2, 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 Br. Another one is CH3, CH2, CH, CH3, Br. So, what is this compound? 1, 2, 3, 4. Butane, 1 bromobutane, correct? What about this? 2 bromobutane. So, here, what type of haloalkane? Primary, because CH2Br. Whereas here, secondary. Okay? When you've got CHBr, for instance, how to identify this kind of compound? Let me say that is CH2X. Okay, so this is primary. And this is the functional group. X is the functional group. And this is the alpha carbon atom. So when the alpha carbon atom have 2H, it is called primary. Are you able to follow? When the alpha carbon atom has CH only, okay, so here you have halogen. So in that case, it is secondary. Do you know why? Because you have got only one proton, okay, one H. This is alpha carbon atom that is. So the carbon atom immediately attached to the functional group is called alpha carbon atom. And how many hydrogen atoms are present? If there are two hydrogen, it is primary. If there are one hydrogen, then secondary. If there is no hydrogen, all are replaced by alkyl group, means tertiary. So no hydrogen. So likewise, you are able to identify. So here CH2Br, so primary. This is CHBr, so secondary. So likewise, you can identify. And you know very well, for non-polar, for SN2, which is favored, primary one. So you have to say primary is supported. Likewise, you can proceed. So let me check up the second one. CH3, CH2, CH, CH3, Br. And here are CH3, C, CH3, CH3, Br. Both are butane only, 4 carbon atom. But this is secondary. This is tertiary. Okay, you know very well for SN2, primary, secondary, tertiary is order. So in that case, tertiary. So this is more filled. Okay, so likewise, you should be able to identify. And similarly, you can look at the question number 6.8, where in the following they ask SN1. We know for SN1, tertiary first, followed by secondary, followed by primary. And it should be polar. Okay, these are the two important things. Now what they are given? They are given as a what? As that is line diagram one. Okay. Now you can expand it as CH3, 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 and C. What is that? This is tertiary. And what about the other one? They are given like this. Bond line diagram. So you can expand it. CH3, CH2, CH, Cl, yes, secondary. We know very well this is secondary, this is tertiary. So tertiary is more powerful than secondary. Okay. So likewise, we can come to a conclusion. Okay. Any doubt?